Alright, good evening everyone. So this is going to be the start of a sort of introductory on how the Apollo spacecraft generates electricity. Well, it does this by making water, safe drinking water. So we need to understand how we can actually get electricity by generating water. And in order to do that, we need to understand what is holding water together. So, this here is a sort of demonstration that I have set up. And this is a voltaic pile invented by Volta. Now, what two British scientists did was they discovered that you can separate water into its gaseous components. But it wasn't until Humphrey Davy ran this experiment that we truly understood what was happening. So this voltaic pile is repeating disks of copper and zinc separated by a layer of cardboard soaked in salt water. The two opposing metals produce an electrical current because they're incompatible. When you end the pile with one metal and end it on the other end with the opposite metal, you form a cathode and an anode. So this is a voltaic pile, and we have two leads going to a beaker of water. Here is our cathode electrical probe, and here is our anode electrical probe. In case you don't know how a battery works, you have a plus side in which electricity is going to flow out into the circuit, and a minus side in which electricity is going to flow in, back into the battery. And electricity, of course, is a steady stream of electrons. So when you supply this constant current to water, what you actually do is you split water into its principal components, gaseous oxygen and gaseous hydrogen. Now, at the time, we didn't know that water was H2O, so we just thought it was HO or OH, depending on who you were talking to. This process, though, is known as electrolysis. What's really interesting is that, as you can see, the hydrogen has collected near the cathode, and all the oxygen has collected on the anode. Now, the reason for this is because hydrogen has a negative electronegative number. So it collects on the positive probe lead, the positive current. This is because opposites attract, much like a magnet, north and south. And oxygen has a positive electronegativity, so it's going to collect on the negative charge lead because opposites attract. So it wasn't until this that we realized that, well, Humphrey Davy made the incorrect assumption that everything was being held together with electricity. There's a lot of stuff that is held together with electricity. This is called ionic bonding. But there's also covalent bonds, which doesn't matter for a fuel cell, so we're not going to cover this topic until probably the hypergolic mixture in the rocket engine. I digress. When you separated these out, you'll see that what you end up getting is 2H2O plus electricity equals H2 plus O2. So we can take this component of water, add electricity to it, known as electrolysis, and get out hydrogen and oxygen. So if we put hydrogen and oxygen together and we get water, shouldn't we also get electricity out because the equation and the energy need to be balanced? And this is what people wondered when they were first making the fuel cell. So this is the sort of knowledge that was discovered in the late 1800s, I believe, that is going to be critical for supplying Apollo with its own electricity. By the way, atoms weren't even thought to have been real at this time. The theory of atoms was made, but chemists thought it was just a handy-dandy tool. They didn't actually believe in atoms until later in the 1900s. I'll talk about that a little later, just because I think it's an interesting fact. Anyways, that's just the pretext of the situation. Have a good one.